In this video, we will do a variety of similarity problems. Find the value of x and y. One thing that jumps out at me is right here. When we have the whole and we have one part of the whole, I know that the other part is going to be the whole minus the part that we already have. So an expression for this segment should be 28 minus x, the whole minus the part. So I can do the side splitter theorem right now. And the side splitter theorem says basically part over part equals part over part. The side splitter theorem basically says I should be able to take these two pieces and make a fraction out of them. And I should be able to take these two pieces and make a fraction out of them. So I just have to decide which direction I'm going to go. So I think I'll do x over 28 minus x. Alright, if I do x minus 28 minus x, I need to, x over 28 minus x, I need to do 8 over 24. Now 8 over 24 reduces down to 1/3. So I've got x over 28 minus x is equal to 1/3. And then I cross multiply and I get 3x. Okay, doing this diagonal, that's 3x. And doing the other diagonal, that's going to be 28 minus x. I need to add x to both sides, so that gives me 4x is equal to 28. Dividing both sides by 4 gives me x is equal to 7. So that was one of my goals. We are supposed to find x and y, and I just found x. So I still need to find y. So I'm going to do a similar thing, another side splitter theorem, using these two. Okay, let's see what I'll do. Let's say I do x over 21. Then I have to do 8 over 2y plus 6. Alright, x over 21, 8 over 2y plus 6. However, we know what x is this time. We know that x is equal to 7. So this makes 7 over 21 is equal to 8 over 2y plus 6. This reduces down to 1/3. So when I cross multiply, when I do this diagonal, I get 2y plus 6. When I do this diagonal, I get 24. Okay, so subtracting 6 from both sides, I get 2y is equal to 18. Dividing both sides by 2, I get that y is equal to 18. So there it is. I have now found x and y. So I need to find the value of x, but the thing that just jumps out at me is finding this missing piece. When I have the whole and a part, I know that to find the other part, I'm going to do the whole minus the part. So what is 104 minus 40? That is 64. So that tells me that this segment is going to be 64. Which makes sense because if I add these two up, I will get 104. Now, so this is the angle bisector theorem. See how I have these two angles marked the same? That means I have a bisector. So we have learned that when we have an angle bisector, then we can make a fraction out of these two numbers and these two numbers, and they should be equal. So for example, 40 over 55 should equal 64 over 12x plus 10. So it's just a matter of simplifying this. Now, hold on while I get my calculator under control here. 40 over 55. 40 over 55. That's 8 over 11. So I've got 8 over 11 is equal to 64 over 12x plus 10. So I need to do this diagonal. So in other words, 8 times 12x plus 10 is equal to, and then I need to do this diagonal. So what's 11 times 64? 704. So doing the distributive property, we get 96x plus 80 is equal to 704. Subtract 80 from both sides, and you get 96x is equal to, so we have 704 minus 80, and that's 624. And then you have to divide both sides by 96. And that's 6.5. So that is the value of x. Are these triangles similar? Well, there are only 3 methods we can use to prove that 2 triangles are similar. We've got side, side, side similarity, where all 3 sides are proportional. We have side, angle, side similarity, where we have 2 pairs of proportional sides and the included angle. And then we have angle, angle similarity, where we have 2 pairs of congruent angles. So looking at what we have, it looks like our best shot is side angle side similarity, because I see 2 sides and the included angle, 2 sides and the included angle. So let's go for side angle side. We don't have 3 sides. This side is blank, so we don't have 3 pairs of proportional sides, and we don't have angle angle similarity. We have 1 pair of angles, and that's all. So this is all we have, side angle side. Now be careful. In order for these 2 triangles to be similar, these S's don't mean that the sides are congruent, of course, because we can have a big triangle and a small triangle. These sides must be proportional. But which sides are corresponding? Look at the first triangle. What is the biggest side? 56. Look at the second triangle. What is the biggest side? 40. So those are corresponding. Okay, so let's do 56 over 40. Okay, now, of course, that leaves the smaller sides. Boom, boom. If we make a fraction out of those, that would be 44 over 33. Now, if these are equal, then we will have side angle side similarity, because the corresponding sides will be proportional. If these are not equal, then the triangles are not similar. So let's check it out. Okay, 56 over 40. 56 over 40. That's 7/5. Now 44 over 33. That's 4/3. Alright, 7/5 does not equal 4/3. So these sides are not proportional. So we do not have side angle side similarity. Okay, so are these triangles similar? The bottom line is no. But you have to show your calculations. Okay, given that triangle RST is similar to triangle KLM, one of the following statements is true. Well, before I even look at these, remember that when you have similar figures, the corresponding angles are congruent. Angles are congruent. However, the sides are not congruent. We have a bigger triangle and a smaller triangle. Of course, the corresponding sides are not congruent. They are proportional. So, when it says RS is congruent to KL, that's nonsense. Alright, these are corresponding sides, RS and KL. But they are not to be congruent, they are proportional. Okay, only the angles are congruent. So sure, angle T and angle M are indeed congruent. So this is true. Explain what is wrong about the other statement. So we're supposed to explain what is wrong about the other statement. When two triangles are similar, corresponding angles are congruent, whereas corresponding sides are proportional. So, of course, these corresponding sides, RS and KL, are not congruent. Big triangle, small triangle, hello, they are not congruent. Corresponding sides are proportional. Corresponding angles are congruent. So that's what's wrong with the other statement. Okay, looking at problem number 5, it says which side length will be easiest to find? PQ, which is right here, QR, which is vertical, or RP, which is the hypotenuse. Well, I'm going to go with QR, okay, because that is a whole number. PQ seems to be about 2.5, but what if it's 2.6? I don't know. QR seems to be a whole number. In fact, it seems to be 3, 4, 5. QR seems to be 5. The other numbers are not so certain because P is uncertain. Okay, so we have QR is equal to 5. Now, find the length of the corresponding side of the smaller triangle. Well, that is 2. Okay, that is 2. Now, what, so maybe I should write that down. So I have Q prime R prime is 2. What is the correct scale factor? Well, guys, remember scale factor, which I will use K to represent, is always new over old. Which one of these is new and which one is old? The primes are new. P prime, Q prime, R prime, the primes mean that this is new. So that's why I'm going to do new over old will be 2 over 5. So that's the scale factor. We're supposed to explain our choice. New over old. That's my explanation. Alright, problem number 6. We are given that triangle FGH, shown here, is similar to triangle DEC, which is shown here. We know that that is true. So, angle F is congruent to what? Well, looking at the order of the letters, angle F is congruent to angle D. Okay, so we know that angle F is 63, so label its partner angle with a 63. So angle D is 63. Okay, like we said. Now, we know that the triangles are similar, so angle C is congruent to which angle? Well, my goodness, angle C must be congruent to angle H because of the order of the letters. So since we know that angle C is 56, its partner angle H must also be 56. Now, the sum of all three angles in any triangle is going to be 180 degrees. So using this information, we can find that the measure of angle G is whatever it is, and that will also enable us to find the measure of angle E. Okay, so they have to add up to 180. So if I do 180 minus 56 and 63, that's 61. Okay, so angle G is going to be 61. Alright, which means that angle E has to also be 61 degrees. Well, problem number 7. Describe how these pictures are labeled differently. Then explain how those differences change the similarity statement. Well, let's start with saying what's the same. SR is 14 and TR is 12 for both pictures. So the changes happen down below. In the upper pair of triangles, the upper picture, RP is 6. In the lower picture, RP is 7. In the upper picture, RQ is 7. And in the lower picture, RQ is 6. So here I've just written down that information. Now, how does that affect the similarity statement? Remember that we have to pay attention to which sides are corresponding. So in picture A, the largest side of the top triangle is 14. And for the bottom triangle, the largest side is 7. So that means that these are corresponding. Okay, and then this is smaller and this is smaller. So those are corresponding. So when it comes time to talk about the order of the letters, okay, we know that these angles are going to be congruent because vertical angles are congruent. But look at the pattern. Angle S, okay, so angle PQR, so angle P is connected to the 6, which is blue. Okay, I'm going to double mark this. So angle P is connected to the blue, and angle T is connected to the blue. So angle P is going to be in the same position as angle T. Okay, so this is going to be the correct similarity statement. Angle P does not correspond with angle S. Okay, angle P is touching the blue, angle S is touching the yellow. Alright, those do not correspond. Okay, looking at this picture, again, you have to pay attention to the sizes. The biggest side of these two in the top triangle is 14. The biggest side down here is 7. Okay, and then that means the smallest will be 12 and 6. So these are corresponding sides. So when I want to talk about corresponding angles, okay, look at angle P. Alright, angle P is over here touching the yellow. That corresponds with angle S touching the yellow. So P corresponds with S. Those two should be in the same position. So that tells me that this is going to be the similarity statement. P does not correspond to T. All right, P is touching the yellow, T is touching the blue. Those do not belong in the same position, so I know that's not the answer. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.